rate problems, we have to be a little bit careful because the rates are proportions. So we can't just easily add them together. Okay? And we need to make sure we're keeping track of the direction of the rate of comparison. And it's important to keep track of units when we do this. So we have a problem here that Jane can paint a room in 3 hours and Kevin can paint the same room in 4 hours. Working together, how long will it take to paint one room? Well, if we just add these two together, it doesn't make sense, because if one person can do it in 3 hours, they both working together and helping each other out are going to do it in 7 hours. So that doesn't really make sense. So how can we do this so that we can figure out how we can put together their working rate? And to do that, we actually have to put it in a rate. So the rate's going to look like this. For Jane, it's going to be one room in 3 hours. For Kevin, it's going to be one room in 4 hours. And we want to keep track of this. Okay? Again, it's important to keep track of the rate, and important to keep track of the direction of comparison so that we know what's going on. So it looks like here, if I were to kind of estimate, well, Jane should paint a bit more of the room than Kevin. So it should kind of look like that if I were to kind of compare Jane and Kevin. So there's Jane's painting. She paints the room. She's going to paint a bit more because she works faster, because she can do more work in the same amount of time. Okay, so when I write this as a fraction or a ratio, this fraction is bigger than this one, which makes sense because the rate is bigger. Now, when we want to combine these, well, we can add rates together. The speed or rate at which Jane works and the speed or the rate that Kevin works, we can say that their rates combined will give us the overall rate. This is the overall rate. So if I want to calculate the overall rate, all I have to do is then break this down. Well, I need to add fractions. I need a common denominator. So what I'm going to say that in 12 hours, Jane can do 4 rooms in 12 hours, and Kevin can do 3 rooms in 12 hours. And that makes sense because Jane is the faster worker. And together, well, if they're both working for 12 hours, they're going to get a total of 7 rooms completed in 12 hours. Okay, so but we don't want to know how many rooms they can do in 12 hours. We want to know how many hours it takes to do one room. Well, hours per room, we need to flip that around. We know that the rate together is 12 hours for 7 rooms. So together we just need a unit rate. So we're going to divide that to get a unit rate. How many hours to do one room? So 12 divided by 7 gives us 1.714. So I'm just going to round that to 71. That's how many hours it takes to do one room. So that's the solution to our problem. And that makes sense because they're working together. They're going to work, Kevin's a little bit slower, so it's not going to take half the time. If they work in the same amount of, at the same speed, it will take half the time. So it's going to be somewhere between, 2 hours, which is if 2 Kevins worked, and 1.5 hours if 2 Janes work, and that looks like it's somewhere in between that. Okay, and this is the rate at which we can do per room. We solved it instead of hours per room, we solved it as rooms per hour. But as long as we keep track of the units, we can just flip that rate around and get the overall rate.